You ever have those nights where you're staring at a CAD model and it feels like you've cracked the code? Everything is sleek, the tolerances are tighter than a drum, and you think, finally, I've designed the Ferrari of brackets.
Oh, I know that look. That's usually the night before you walk into the machine shop and the lead machinist looks at your drawing like you just handed him a napkin covered in crayon drawings.
It's worse than that. It's the look of pure, unadulterated pity. I walked into Miller's shop last Tuesday with this aluminum housing. I'd spent 40 hours on the internal fillets, making them perfectly aesthetic. Miller just pushed his glasses up, sighed heavy enough to move the sawdust on the floor, and asked me if I'd invented a square-shaped drill bit while he wasn't looking.
Let me guess. You put sharp 90-degree internal corners in a milled pocket?
I wanted it to look architectural, Alex. I wanted crisp lines. I forgot for a hot second that end mills are round objects that spin. If you want a sharp corner inside a hole, you aren't just asking for a part. You're asking for a miracle or a very expensive afternoon with an EDM machine. And Miller doesn't do miracles on a Tuesday.
Welcome to the Tiger Den, everyone. Today we are stripping away the ego of the designer and getting into the gritty, oily reality of DFM, designing for manufacturability, specifically in metal. Because as Tiger just illustrated, just because you can draw it in Fusion 360 doesn't mean the physical universe is going to let it exist without a fight.
That's the heart of it. Designing for metal is really a conversation between your imagination and the physics of the tool. When we talk about DFM, people think it's about making things cheap. It's not. It's about making things possible without going gray before your 45th birthday.
Okay, so let's start with the impossible versus the expensive. Because usually, when a machinist gives you that look, he's calculating how many specialty tools he's going to have to buy on your dime. What's the biggest sin you see people committing when they start transitioning from wood or 3D printing into metalwork?
It's the material disrespect factor. If you're 3D printing, you can grow a hollow sphere inside a cube just for fun. In metal, every gram of material you don't want has to be physically carved out, ground away, or melted. The biggest sin: deep, narrow pockets.
Give me the Tiger physics on that. Why does a deep hole make a machinist want to retire?
Think about holding a pencil. If you're writing normally, you've got control. Now tape that pencil to the end of a 3-foot yardstick and try to sign your name. That's tool deflection. The deeper you go, the longer the bit has to be. The longer the bit, the more it wobbles and screams. And when a carbide bit starts screaming, it's usually right before it turns into shrapnel.
So the rule of thumb is what? 3-to-1? 4-to-1?
If you can keep the depth of a hole to less than 3 times the diameter of the tool, you're in the Christmas card list territory. You go over 5 times, and you're paying for the machinist's next vacation because he has to slow that machine down to a crawl just to keep the tool from snapping.
Let's pivot to the stuff you're actually good at, welding. I've seen you look at engineering prints for welded assemblies and just start rubbing your temples. What are we doing wrong on the paper side that makes life miserable at the welding bench?
Accessibility, Alex. It's the ship-in-a-bottle syndrome. Engineers love to tuck a beautiful fillet weld inside a box where no human hand can reach. They'll design a chassis where 4 tubes meet at a weird compound angle, and they expect me to get a torch in there. I'm a welder, not a ghost. I can't pass my hand through solid steel to reach the backside of a joint.
So you're saying we need to design with the torch path in mind.
Exactly. If I can't see it, I can't weld it. And if I can't get the ceramic cup of my torch within half an inch of that joint, you're going to get a weld that looks like a bird with a stomach virus visited your shop. You have to leave room for the silhouette of the tool. It's the same with fasteners. People design these intricate blocks where the bolt head is tucked under a ledge. Sure, it looks clean, but how am I supposed to get a wrench on it? Do I need to buy a specialty S-shaped wrench from a wizard?
A bird with a stomach virus. Moving on from your poetic descriptions of bad welds, let's talk about tolerances. I feel like this is where the money goes to die.
This is my white whale. Listen, if you tell a machine shop you need a part that is plus or minus 5/10,000ths of an inch, they will give it to you. But they will also send you a bill that looks like a phone number.
Because perfect is the enemy of profit.
It's the enemy of sanity. I once saw a guy specify a tight tolerance on a decorative coat hook. Why? Unless you're hanging a coat made of liquid mercury, a 1/16th of an inch isn't going to kill anyone. In metalworking, every decimal point you add to that tolerance doubles the stress in the shop. You're moving from cutting to grinding or honing.
So for the makers listening, if it's a hole for a bolt to go through, it doesn't need to be a press fit.
Right, give it some air, let it breathe. A clearance hole is your best friend. If you can use a nominal size, stay there. The moment you start asking for dead flat and perfectly square, you're asking the machinist to fight the internal stresses of the metal itself. You take a big chunk of cold rolled steel and start milling one side, the whole thing is going to potato chip on you because those internal tensions are letting go.
Potato chip. I'm adding that to the Tiger Dictionary. Let's talk about sheet metal for a second, because that feels like a totally different beast. Everyone thinks they can just fold it like origami.
Sheet metal is the most deceptive medium. It looks like it wants to cooperate, but it's got a memory. The biggest DFM mistake in sheet metal is forgetting about bend allowance and K factor. You can't just draw a box that's 10 inches wide and expect it to be 10 inches after you fold the sides up. The metal actually stretches on the outside of the bend and crushes on the inside.
And if you put a hole too close to that bend line,
Oh, then you get the eye. That beautiful circular hole you precision drilled. Now it's an oval because the bending process dragged the metal along with it. It looks like the part is winking at you, mocking your lack of foresight. You've got to keep your features away from the distorted zone of the bend.
what about minimum bend radius? I see people trying to get these razor-sharp corners on 1/4 inch plate.
That's a great way to crack your work right down the middle. Metal has a limit to how much it wants to be squished. If you try to bend it too tight, the outer grains of the steel just give up and separate. It's like trying to fold a piece of dry toast. You want a radius that's at least equal to the thickness of the material. It keeps the structural integrity, and honestly, it looks more professional. It looks like you meant to do it.
We've talked about the don'ts. Let's talk about the wins. What are the small design choices that make a machinist or a fabricator actually enjoy working on your project?
Standardizing. If your part has 15 different bolt sizes, I hate you a little bit. If you can design everything to use the same M6 fastener, I only have to set up one drill, one tap, and one counter bore. It's a flow state. The moment I have to stop the machine to change tools for one special hole, the rhythm is broken.
Efficiency is a beautiful thing. What about tab and slot design? I see that a lot in your work lately.
That is the cheat code for metal fabrication. If you're building a complex assembly, don't just butt two pieces of metal together and hope your magnets hold them square while you weld. Give one piece a little tongue and the other a little groove. They snap together like Lego.
It's self-jigging.
Exactly. You aren't fighting the piece anymore. You're just zipping the seams. It ensures everything is square. It makes the assembly 5 times faster, and it makes you look like a genius who doesn't need a square. Which is good, because I haven't seen my favorite square since 2018.
It's probably under that pile of architectural fillets you cut off that aluminum housing.
Probably. But listen, the real takeaway for DFM is this. Go talk to the person who has to make it. If you're sending a file to a local shop, call them. Say, hey, I'm about 80% done with this design. Is there anything here that's going to make your life a nightmare?
That seems so simple, but most people are intimidated by the cranky machinist stereotype.
We're only cranky because we're tired of trying to figure out how to drill a hole around a corner. If you show up and show that you're willing to move a wall by 1/8 of an inch to make it easier to clamp, we will follow you into battle.
So, simplify the tools, respect the bend, and don't make the metal scream.
That's it. Metal isn't your enemy, but it's definitely not your servant. It's a partner. You got to listen to what it can give you. If you try to force it to be something it's not, like a perfectly sharp internal 90-degree corner, it's going to win that argument every single time.
I think that's a perfect place to wrap. Before we go, what's the one thing everyone should check on their drawings tonight?
Check your fillets. If they're all the same size and they match a standard tool diameter, you've just saved yourself 3 digits on your next invoice.
Good looking out, Tiger.
Go make something. Just make it possible to make, all right?
See you next.